Hello, hello. Am I audible? Yeah. So, hello everyone. I'm Tilak. So actually, I'm from CDAC Bangalore Quantum Technology Group, and today I'll be mostly speaking about. Today I'll be delivering my talk in primarily two segments. The one is first I'll describe a platform called QNIVERSE, what it is, what it's good for, what kind of things you can do with it as a students, young researchers like all of you. And secondly, I'll showcase an algorithm, specifically the time evaluation of a quantum system, which I actually implemented that algorithm into the platform in QUniverse itself. So these will be the two segments of my talk. In the second session, I'll be giving the algorithm demonstration that are based on the trotterization. In the first segment, I'll be giving the talk on hands-on demonstration on QUniverse. So, so So just to begin with, how many of you are just a beginners in quantum computing? Raise your hands. Okay, a lot of them. Okay. Now I'm actually very worried about should I really discuss about trotterization based on those algorithms because it's a bit tricky. But if you stay a bit patient, you will maybe have a much more intuitive understanding. Okay. No, but still, I'll try my best to explain things in as simple as possible so that all of you have a really good understanding and get benefited from this platform. Yeah. So, as I said, most of you are just a beginners and probably does not have a really good understanding about quantum mechanics or quantum computing. So, I think so. I can start off this talk with this famous quote from Richard Feynman, which is a famous physicist. I think all of you have heard about him. So he said something like, I think I can safely say that nobody really understands quantum mechanics. So even such become as a prominent speaker, like as a prominent scientist like him, even he can say this fact with such diligence. Maybe we can accept that we are also some kind of a beginner in quantum mechanics. Anyway, so his main point is was to point the to attempt uh, was that to attempting to use the classical analogies. So, for example, our intuition, whatever we see around ourselves, whatever we feel around ourselves, how we see things, our intuition is based on that only. So, for example, if I ask you a simple question, what will happen if I throw a ball from here to there? All of you will be able to answer it without understanding quantum mechanics or without understanding any algorithm whatsoever. So you'll be able to say, okay, this ball will travel this much far. This will probably follow this kind of trajectory. Now, how do you know that? Because since you have born, like uh, uh, you have built your intuition throughout your childhood. Like you have that in your feelings. Like, okay, this ball will travel with this in this particular fashion. But in quantum domain, we don't get to visualize, or we don't have the intuition to understand what is going on. So the only way to describe, or the only way to know what is going on, is by following the mathematical analogy. So which is, I feel like, probably the best way to understand quantum mechanics is you just understand mathematics step by step, and that clarifies a lot of things. So that's exactly what you have highlighted. So the behavior of the subatomic particles is fundamentally different from anything we experience in our daily lives. So which highlights that its principles are deeply counterintuitive and disobey our everyday experience. So as I said, in the first talk, my agenda, I'd be speaking mostly about why we need Universe, what it is and how it works, and I'll be showcasing some live demonstration. And as students as well as researchers, what kind of educational and research value you can get from it. So I think these are the type of different quantum hardwares that are available right now. So one is superconducting qubit based quantum computers. Another one is a trapped ion based quantum computers, the photonic quantum computers, and neutral atom quantum computers. So there are other uh, different kind of hardwares also available, but these are the mostly prominent and the famous ones. Now the major players of each of these superconductor quantum computers, are already mentioned, such as IBM, Google, Rigetti. In the trapped ion segment, mostly IonQ and Quantinum, and the photonic quantum computers, Xanadu, PsiQuantum, and the neutral atom quantum computers, it's QERA, Pascal, or atom computing. Now, the problem with different kind of hardware is that each of the quantum hardware requires its own SDK framework. So, for example, if you want to do or learn about superconducting qubit based system, you need to learn Qiskit, right? If you want to do understand, or let's say implement your algorithms into a ion trapped quantum hardware, so you need to understand circ. uh, Similarly, for photonic systems, you need to understand, or you need to have an intuitive, a very good grasp on strawberry fields, as well as in for the GPU based simulation, you need to have a good understanding about CUDA-Q. So that's where the problem is, that you have to master a lot of frameworks to really do quantum research in terms of algorithms. So as an algorithm developer, I don't feel like you should learn all of it, because most of your focus should be learning and developing those algorithms rather than learning different kind of frameworks. Of course, it definitely helps, but yeah. So learners and researchers must understand that multiple frameworks uh, to run the same kind of an algorithm in different hardware, which actually slows the process and creates a lot of confusion. So to gather more data, we actually, our team CDAC ran a big survey with around 200 participants. So we asked a different bunch of questions. The first question is, what quantum computing frameworks are you currently familiar with? So 57% people replied with, okay, we are mostly familiar with Qiskit. 8% replied that we are mostly familiar with Circ, and 12% replied that we are mostly familiar with Pennylen, correspondingly for CUDA-Q and other frameworks as well. Which shows that most of the students and participants were mostly familiar with Qiskit. Now, another question that we asked is, how important is it for you to have a single unified platform that integrates different quantum computing technologies? Now, 80% people have came up with a very strong support of it's a very important. Now, somewhere 20% people have told that okay, it's somewhere important, and 1.5% people have actually said that it's not important at all. So as it came from you also, all of you, it's not an exception that how are you familiar with the fundamentals of quantum computing? So most of it just a beginner, even though yeah, most of them just are beginners. So which uh, showcases in this slide also that around 70% people are just a beginner, 20% are intermediate, and 11% are just expert. Now, what are the different problems that we also try to understand that the researchers as well the students are facing currently? Now here's a distribution of it, like hardware constant is 15%, and talent and knowledge shortage is around 26%. Algorithmic challenges are like percent, and other challenges that are also mentioned is also mentioned here. So now these are some of the surveys that we ran, and actually all of this helped us, or all of this kind of survey or kind of questionnaire helped us to or actually motivated us to develop QNIVERSE. um, so yeah, so this is the interface of the QNIVERSE. Now I'll go into it in a very details. I'll try to explain each and every single step, what it is, how it works, how you can get access of it. Yeah. So in short form, what is QNIVERSE is it's an unified platform redefining the way of developers, researchers, and enterprises engage with quantum technology. So as this is an integrated platform for designing, simulating, and executing quantum algorithms on classical accelerators such as GPU, FPGA, and vector processors, as well as we can execute this on multiple quantum hardware platforms. Now, these are some of the features of the QNIVERSE, which I'll explain in the upcoming slides also in details. So as I already mentioned that it allows you to write, you don't have to worry about learning multiple frameworks. So you can learn only one framework, and QNIVERSE will help you to write the same code for same kind of an algorithm in other frameworks as well. So as I said, it's an unified interface. It's a platform agnostic, which enables smooth operation across various quantum hardware. So whatever algorithm that you write, it actually we can integrate those kind of algorithms and execute those algorithms in either CPU, GPU, FPGA, or QPU as well. Uh, yeah. And quantum SDK. So it is built-in libraries which let users quickly integrate on pre-made components into workflows, which actually improves the efficiency of researchers as well as the students. Um, and we have also algorithm palette, where there are existing algorithms that are already there, which which includes a lot of basic as well as some of the advanced algorithms, which definitely you will have a lot of help from that. And it's a hybrid classical quantum workflow. So you can just effortlessly integrate with major quantum providers and param HPC, which our CDAC is mostly capable, I feel like, um, which is high performance computing HPC supercomputers, to enable hybrid workflows, which can help you to combine quantum and classical methods effortlessly. And we also have various kind of tutorials which will not just only help you to understand those algorithms, as well as um, build your own intuition as well as do experimentation uh, in that platform. Yeah, with this I'll quickly go to QNIVERSE. So when you land the page of QNIVERSE, this is exactly what you land upon. So this is the interface of the QNIVERSE, where you will able to see a lot of different things, starting from what it is, a basic intuition, and some of the pictures of what is inside it, as well as some of the FAQs, what kind of what is quantum accelerator, such as what is quantum accelerators, what quantum simulators are supported here, as well as what quantum algorithm implementations. So once you get into this page, you need to have login access. So you can register for it. Yeah. So as I have already some login credential, I'll just quickly log into it. And upon login, so this is the interface it exactly looks like. So so there are a lot of things here actually. So I'll go each and every single thing one by one. So upon login, you will be able to see that there are some single qubit gates, multi-qubit gates, as well as some. So this is the gate palette. I think you can see my mouse cursor. So this is the gate palette, where there are single qubit gate, multi-qubit gates, as well as some advanced gates such as QFT, IQFT, which is quantum Fourier transformation or inverse quantum Fourier transformation. Now you have a blank circuit here, where you can drag and drop of various kind of uh, quantum basis gates, such as Hadamard, X gate, Y gate, rotational RX, RY, RZ, C naught gates, Toffoli gate, CZ gates. These kind of gates, all you can add and create your own quantum circuit. Now uh, here so here you can name your circuit just for the future reference. I'm just for doing it for now, let's say I'm doing it for test. And here you can see the different kind of gates are available, so you can just drag and drop each and every gate. So as this is just a Hadamard gate, so as we all know that Hadamard gate creates equal superposition of the possible number of states. So as I said, as I applied the Hadamard gate on the first qubit, what it will do, it will create equal superposition of 0 and 1. So as this is a, okay, I can reduce the number of the, like how many number of the qubits as well as how many the classical registers I want, I can also manage that. So if I click on manage, so you can see here I can reduce the number of the quantum registers from 2 to 1 and classical registers as well. So yeah, which makes much more sense now. So if I apply a Hadamard gate, so as we know, the Hadamard creates equal superposition of both 0 and 1. So it creates a, here's a histogram of it, like you get 50% of 0 and 50% of 1. Now, just like in the last talk also, he mentioned some of the, he was talking about some Bell states, I think. So here you can also create some Bell states and check, yeah, sorry. Okay, I need one more qubit, sorry. Uh, yeah. So yeah, so which actually is a Bell state. So this is creates a Bell state of 0, 0 and 1, 1. Now on the right side, you get to see the custom code corresponding to this particular circuit. Here you can also create your own code, uh, such as this. Let's say, and it's also built in a very uh, uh, in a way such that if you do any kind of errors, that will also be visible. Uh, yeah. So you can create your own programming. You can create your own uh, coding, and it will create the corresponding circuit on the left side. Now, as I said, QNIVERSE is a unified platform which helps you to transform from one particular framework to another particular framework without putting so much of effort. So here you can see the open Quasam code, and you can directly convert it into Qiskit or Circ without knowing exactly in very depth what how to write the code in Qiskit or Circ or CUDA-Q or Qist, these kind of frameworks. So which helps you to write down codes for different frameworks. Now, yeah. So here is the probability distribution curve, probability distribution. So where you will be able to see what is the state, what is the probability of the output of my circuit. Now you can apply various kind of gates and do some kind of an experimentation with it. Yeah, and see how your state is evolving with certain amount of time. Right. So yeah, so that's exactly how it affects the basis gate, the basis states, and changing the probability of the basis states. Now here is one more cool feature, that is the debug feature. So if you click on it, you will be able to see in which step in my circuit what exactly my state is and how it is evolving with time. So let's say if I have a Hadamard gate, I want to know what is exactly happening after the Hadamard gate, and I don't want to know what is happening after all of the gates applied. So as I said, like this after applying the Hadamard, I'll get this state, this probability distribution, and if I apply it as C naught gate, I'll create a Bell state. Yeah. So then again, if I apply a C naught gate, sorry, X gate, the changes will correspondingly accordingly. So this is a debug feature which will definitely help you to understand each and every step of your circuit and each and every gate what exactly it is doing and how it is changing your state, which I feel it's a very interesting and important thing for students like all of you, which will definitely help you to understand how a quantum circuit or quantum algorithm actually works in a much deeper way. Now here in the bottom side, you can see this is my circuit IDs, which is mentioned here, as well as you can see the status. Now one more thing, you can just extend it into fully expanded, and yeah, so this is the full circuit. You can do a lot of experimentation and yeah, so probability, yeah. Mm, wait. Yeah. So here you'll be able to see the different circuit IDs. So once you create your circuit, you just can, okay. And one more thing, without measurement gate, you cannot run your circuit. So you have to put the measurement gates to run your circuit, right? uh, because that's what measurement gate suggests. So it will run the circuit, and let's say for 10,000 times, or for 10,000 shots, or 1,000 shots, and it will create the histogram based on that. So here you will in that histogram you will be able to see how the probability distribution works. But when you actually run this circuit, uh, you will yeah, you will need the measurement gate. Without measurement gate you cannot run a circuit. So once you hit the run button, you will have a different kind of backends, starting from CPU, GPU, and QPU as well. Yeah. So we have integrated the QPU of Super Stack hardware based on their API keys, and you can just implement your algorithms in CPU, GPU, and QPU as well. Now, if I just hit the submit button, yeah. So as I said, that this 10,364, this is my circuit ID that I have just submitted, and the current status is it's running. Once it's get done, it will have a green tick here. Now, it will take a bit of time based on the depth and the complexity of your circuit. Now, in the meantime, I'll describe the other features also. Yeah. So this is the quantum composer that mostly I described till now. So here you have a algorithmic palette where, as you can see, all the basic algorithms, starting from some of the basic algorithms as well as some of the advanced algorithms, are pre-built. So you can just load circuit and check the circuit and see how it exactly works. So in a sense, QNIVERSE will also help you to understand or create intuition about different kind of algorithms, and exactly understanding how the algorithms are actually working, right? So for example, yeah. So for example, if I pick a simple Deuce-Josh algorithm, I think all of you have heard about Deuce-Josh algorithm. It's one of the most basic algorithms. If I choose it for 2 qubits, or let's say 3 qubits, and where if x0 suggests my either the function is balanced or constant function. So if I just if I hit the load circuit, so this is the corresponding circuit that I'll have. And if I hit the run button, submit, if I hit the run button, so again my job ID is been created and my circuit is been yeah, my circuit is been implemented, sorry, my circuit has been executed in CPU, as I have chosen CPU. Now I can see the status also. Here I can see the probability distribution of this whole circuit. Um, so it will take a bit of time actually, I think. So here you can see it's in Q, which some of the details of the circuit is mentioned here, which is circuit name is Deuce-Josh algorithm, and resources that I have used is QACC cluster, CPU based, and I am using Quasum simulator, and the status of it is queued. So that means it's still running. So if I hit a couple of refresh button, so yeah, you see I have got my output. So if you have some kind of an error, you will have the error here. So which I don't have any. So yeah. So yeah. So just the Dewey-Joshi algorithm suggests that the state will be in 0, 0, 0. Now there are other algorithms as well, such as superdense coding, quantum Fourier transformation, quantum phase estimation, as well as some of the time evolution algorithms based on totalization. So this algorithm I'll explain in details in the upcoming after lunch. So hopefully you will have a good understanding about it. Yeah. So these are some of the algorithms. Here are already implemented by our team CDAC. So you can explore all of them once you have the access. Now the next thing that I want to discuss is the job section. So yeah. So just I created this, I just submitted this job of Dewey-Joshi algorithm just a couple of minutes ago. So here you can see the status of it. You can see all of the status of whatever the circuit you have ran till now. So yeah, so you can see all of them here. So this is actually says the Dewey algorithm is you can check what is the status is here from here also. Yeah. So I think which I have already said in the last segment. Now here's the documentation part. Now just creating your own circuit and making your own circuit uh, does not help you to really understand any algorithm from scratch. So for that, we have written some tutorials, as well as we have written all of the tutorials basically, and the in-depth each and every single step of all of the algorithm that you have seen here, how it is working and what are the various steps are. You can explore those things here also. So just here in the introduction of universe, and then you will have building circuits, how we can build a circuit, as well as what kind of backend systems you are using. Uh, yeah, and once you uh, done with that, you can create new kind. You can understand the algorithms part also. So such as if I just a home button, okay. Mhm. Yeah. So in the QSDK section, you have various kind of algorithms starting from Simon's, Bernstein, Vezzarani, Dewey Josha, Grover's algorithm, quantum teleportation, and all the algorithms that you have seen there in the palette. So all the tutorials are available here. So by reading all of this and by starting to understand all of this, you can have a much more understanding, much more deeper understanding about each of this algorithm. For example, if I just click on, let's say, quantum teleportation, or uh, let's say let's go with a very simple one, Bernstein Vezzarani algorithm. So you can see the tutorial is already available, and if you have some kind of a difficulty understanding about it, so there is some short video clip also available, so that you can build a hands-on intuition. I think, am I audible? Yes. Yeah. So as I was saying that here you can see the tutorials, the written form of the tutorials of all the algorithm, all starting from all the basics algorithms as well as some of the advanced algorithms. And what's the most interesting and most important thing about this section is it's created in such a way that it is a very it gives you a very step by step approach. So in spite of putting it all together, so yeah, I think it's a general process for learning any complex thing. So you break that whole thing into very small steps, right? And you go each step at a time. So if you follow this kind of a strategy, you can learn anything, not just specifically any quantum algorithm, but in general in any life. That's what I feel. So in that sense, I feel like it's been broken into a lot of steps in a very simple step by step way. It has been written in here, so which will definitely help you to understand it. um, uh, and you can do your experimentation with, yeah, you can do your experimentation. Uh, Once you have a build understanding about this algorithm, you can play with the circuits, or you can play with creating new circuits based on whatever algorithm that you have learned. So that's in a sense a very unique platform, universe. So yeah, so once you register, so one thing that I forgot to mention is you have some balance. So once you register and you have an account, you will have around 150 credits. And uh, each time you run a circuit, so each time you run a circuit, once you create your circuit, based on if you're running it on a CPU, or if you're running on a GPU, or if you're running on a QPU, uh, based on that, some amount of credit will be deducted from your account. Now, this way, once your credits are all gone, then you need to have again contact our team to maybe refill it. And there is also a redeem system there. So maybe you have to incorporate that also to get more credits. Yeah. So yeah, as I was discussing in the documentation section also, here you will have user guide as well as a QSDK where you will get all the documentation of all the algorithms as well as the FAQ and some troubleshooting. So what are the problems with different kind of if you face any problem, you can search your questions here. Maybe FAQ we will help you to answer that. And there is one more thing which you call it as a Q assist, which is more like a mini chatbot, mini chat GPT in this platform. So what it will do, it will navigate, it can navigate to you based on whatever you need, and you can get to know about what is the current status of your job ID by chatting with this. So for example, if I want to know the latest job that I have submitted in the backend CPU in the cluster, so the job ID is 10,365. So if I just simply ask my Q assist what is the current status of the job ID, what is it, 10,365, right? So if you just um, do this, it will exactly give you 10,365. Sorry, I made the number mistake. Sorry. 65. Yes. Yeah. So I think it will showcase what is the, yeah. So as you can see, job use Josh algorithm that I have just submitted in the backend with job ID. This was completed in with mentioning the date as well as how much time it took in the Quasam simulator using the Qiskit and CPU accelerator within the QACC cluster environment. So if you just click here, you will get the full details of it. Yeah. Um, yeah, and one more thing is launch notebook. So where you can create and build your own algorithm from scratch. So you can use, so this is the notebook environment that you will get. So where you can build and create your full algorithm based on either it's a Qiskit based or Circ based. You can write this algorithm from scratch and you can test it using this notebook. So yeah. Mhm. Yeah. So yeah, I hope I have covered it. So if you have any questions, you can ask me. One more thing is if you want to execute those quantum circuits into some quantum hardwares such as QPU, you need to have API key of SuperStack. So because CDAC still does not have uh, quantum reference facility, which will soon will have it in very in let's say in upcoming months, but we are still using SuperStack API key. So before submitting your jobs into a quantum processing unit, you have to have SuperStack API key. So once you click here, you will be able to create, you will be able to generate your account in SuperStack, and once you do that, you will be able to see your SuperStack API key. And once you have that API key, you can execute your all your jobs into QPU as well. So with this, I think I covered all of the points. So yeah, you can ask me any questions if you want. No questions? No questions. Come on, ask anything.
Hi, sir. Sir,
Yes.
do I need, sir, like in the while creating the account, we will be getting 150 credits or some other credits, right, sir?
Uh,
So one all the credits that I have, like if all the credits that I have used were over, so how can I get the new credits? Do I need to
yes.
purchase plan or do I be having any kind of referral system to earn more credits?
Yes. So for that, you need to contact our CDAC team to get more credits. So we have a kind of a redeem system. So if you go here, um, yeah, so just you can see here. So once if you are in a free plan segment, you will get 150 credits just after your registration. And if you apply your jobs on CPU, it will be deducted 5 credits. If you apply it on GPU, it will be 10 credits, and QPU will take 2 credits. So once you will done all of your credits, like once you run up all your credit points, so you have to redeem it. You have need to have a coupon code, or you can directly contact our CDAC team, which will definitely guide you to get more uh, credits or redeem points.
And also, so on top of that, do I get any kind of daily free credits as well?
Sorry, what?
So, like, do I be getting any kind of daily free credits?
Tele? What? Tele?
Free credits daily, like 5 free credits for every usage that I do on daily purposes. Like what I'm exactly asking is if I am run out of all the 150 credits or while I'm using the 150 credits, do I be getting any kind of free credits daily? Like some other platforms offer 5 free credits for every day, right? So do we got all do we also have such kind of feature? I'm asking.
Not exactly. So I think some sound disturbances came. I couldn't hear you properly. So what exactly you're asking? Like,
Like do we got free?
Sir, some platforms are offering daily free credits,
uh
daily 5 credits of free like that. So, do your platform also offer daily free credits like that? He's
yeah,
asking that.
these 150 credits are completely free. So once you register it, these 150 credits are completely free, which you'll get after registration. And once you run up, once you used all of your credits, and how it will be get deducted, so based on these matrices. So for CPU usage, 5 credits will be gone, for GPU 10 credits, and QPU 2 credits. So in this way you can calculate how much circuit, how many circuits you can actually run. So once you run up all your credits, then you have to contact us, or maybe to have a redeem code, or maybe you have to purchase more credits.
Okay, so thank you.
Okay, thank you. Yeah.
Thank you, sir, for guiding us about QNiverse. Recently, I am enrolled in QNiverse Developer Certification course.
Mhm.
For that, we need to submit job IDs, sir.
Hmm.
Past 3 months back, I created IBM Cloud account. How can I include this into this, sir? That account, that ID to this. Are you understanding my point?
You want to include your IBM account into QNIVERSE?
Yes, sir.
Yes.
How
So
to?
earlier IBM, you had that facility to integrate IBM's API key as well here in QNIVERSE, but right now it's been disabled by IBM. So we will have our own reference facility very soon, like our own quantum computer, like a
But
60 qubit system. So then once you have your algorithm ready, whatever QPU, whatever, if you want to choose your algorithm to run on a QPU, so it will exactly run on our QPU. So you don't need actually IBM's API key actually for that.
sir,
After that.
in the form, we need to submit the job IDs, sir.
Mhm.
Job IDs. We need to submit the job IDs.
Yes, job ID. Yeah,
How can we get job IDs after the run
yeah.
of
After
our
the
circuit?
run here,
Yes, sir.
yes, yes,
In
of course.
QNiverse.
So after, okay. So let's say I pick a simple algorithm, just algorithm. So if I just hit the run button, so see my balance is around 90 credits. So here, if I choose CPU, I'll be taking, like 5 credits will be taken for GPU, 10 credits will be taken, and corresponding for QPU as well. Now, if you choose QPU,
Take least
right?
credits.
So you need to select the super stack hardware, right? And once you submit it, like let's say I want to run it for the GPU. Okay. So yeah. So your question was how to get the job ID, right? So here you can see once you submit your job, yeah, your job ID has been created here. So you see 10,369.
So circuit ID and job ID are same, sir.
Yes.
Okay,
So,
sir.
and correspondingly, you will be able to see the status also. Now, if that does not make you, like if that does not answers your question, you can directly go here. Okay. Uh, and get into the job section where exactly we'll get, I think, yeah, here is a job, the last job that I have submitted, which is still on queue. Here is your job ID. I think it's still in running. So yeah, so here is the job section again. Yeah, it's completed now. So this is your job ID. Job ID and circuit ID is basically same.
Both are same.
Both are same.
Thank you, sir. Thank you, sir.
Sir, is there any other platforms which are offering the same features like this?
So that's why QNIVERSE is the most unique platform, because same feature by meaning that you will, I think there is no platform available where you will get the tutorials of various kind of algorithms to already uh, pre-created algorithms that is already available in the platform, as well as you need not to learn different kind of frameworks. So if you learn only Qiskit, the corresponding different frameworks, coding will also be available, programming will also be available. So in a sense, in these perspectives, so I feel Universe is the most unique platform, and there is no other platform which is offering in these three, all of them three.
Okay, sir. Thank you, sir.
Yeah, that's it. So I think in the next session, I'll be talking more about physics aspect of which is my core expertise, I feel. Physics aspects of how does a quantum system evolves with time, and how we can create a equivalent circuit of it. So I'll going into that in a very detailed and a very, I feel like all of you have a much more intuitive understanding about that algorithm. So yeah, I feel like you will have a great time if you yeah listening to that talk. Yeah. So with that, I'd like to end my talk. Yeah. So that's done. Yes. Anything else?
Sir, who on earth will not be fascinated by hearing on such a stage like Qiskit Fall Fest that you do not need to be a pro coder to code quantum things, and you can simply do quantum circuits by just using GPUs, like simple designing. So this session is, of course, so fascinating and insightful, sir. Thank you so much for your valuable time and the insights you gave us. Thank you so much from all of us, sir, on behalf of all of us. A big thank you to Mr. Tilok, sir, for taking the time to guide us and for sharing such valuable insights. The session has truly made quantum computing feel accessible, exciting, fun, as well as practical for all of us. So let's give him a very big round of applause for all his efforts and knowledge he has shared with us. Thank you, sir. And so, dear participants and everyone, it's now time for a well deserved lunch break after all the sessions and after all the knowledge you have grasped from morning onwards. And so, take this time to refresh and recharge so you can come back with full energy and curiosity in the afternoon sessions and get going with the remaining sessions of the day 5. There is way more knowledge coming your way, guys. So, enjoy your lunch and we'll see you back here very soon for more exploration, learning, and innovation. Thank you, guys. Please fill out the feedback forms to confirm your attendance of the sessions and also give us your valuable feedback.